already have. What are the equations? Let me just quickly write here. A is equal to Q naught B plus R1. B is equal to Q1 R1 plus R2. R1 is equal to Q2 R2 plus R3. Like this it goes on and on. Okay, goes on till we hit Rn has to be equal to 0. So if I have Rn minus 1 here, then here I will have Rn minus 2 or Rn minus 1 I have here. That means Rn minus, okay, so Qn minus 1 Rn, no, Rn minus 2, n minus 2. This is Rn minus 3. Have I written it correctly? This is one more, this suffix is one more than this. Yes, so n minus 3, n minus 2, n minus 2, n minus 1. And after that, I will divide Rn minus 1 is non-zero, right? Rn is also non-zero. I could have written that equation itself. Anyway, so Rn minus 2, next we are dividing Rn minus 2 by Rn minus 1. So that gives me Qn minus 1 Rn minus 1 plus Rn. I hope you can see this, okay? Rn minus 2 is equal to Qn minus 1 times Rn minus 1 plus Rn. And there is one more equation, that is, we are dividing Rn minus 1 by Rn. That gives me Rn minus 1 equal to Qn Rn plus Rn plus 1, but this is equal to 0. So here the process stops. So actually Rn divides Rn minus 1. Now we use this equation. You see, GCD of A and B is equal to GCD of B and R1. In the same vein, GCD of B and R1 is equal to GCD of R1 and R2, because the structure of the equations are same. And it continues like this. Ultimately we will get this is equal to GCD of Rn minus 1 and Rn, which is equal to GCD of Rn and Rn plus 1, which is nothing but 0. Now what is the GCD of 0 and this? Rn. Why? Because Rn divides both 0 and Rn, and this is divisible by anything that divides 0 and Rn. That's why Rn is the GCD. If you have two integers, one of which divides the other, the dividing integer is the GCD, provided that is positive, of course. And here Rn is positive because this is the last positive remainder. After that we get 0. So let us write this systematically. So using the given equations, we just have to write this sequence of equalities. B comma R1, that is equal to R1 comma R2, and it goes like this. Then we have Rn minus 1 comma Rn, which is equal to Rn comma Rn plus 1. That is nothing but Rn comma 0. So So this is equal to Rn, and that's what we have to show. Rn is equal to a comma b. So this completes the solution to this exercise. Now we are going to use this algorithm to calculate the GCD of two given integers. The calculations I have already done, so that I don't have to do it here, since that's not the point. So we come to the next exercise, which is numerical. Exercise 7. So use the method in exercise 6 to calculate the GCD of 1128 and 33, and I can just okay, let me write it the way he has written, Herstein, and the GCD of 6540 and 1206. So we just have to continue applying the Euclidean algorithm the way it's prescribed in the previous exercise. So for doing that, first of all, we divide 1128 by 33. The quotient turns out to be 34, and the remainder is 6. You can verify this. Then I divide 33 by 6. Then I divide 6 by 3. So you can see that I have got 0 remainder here. So according to my previous exercise, this is the GCD. Okay, so by the previous exercise, this is the GCD 33. For the second one, I will not show the steps, I will just simply write the answer, because you can do it yourself. This turns out to be equal to 6. Okay. Next,